order of operations here, and this would be mental math. And if it's not mental math, it would have to be written out of algebraic. We don't let them write out, just let them write all over the place. For quick division, they actually have to understand that there are not that there's 3 16s in 48, but there are 30 16s in 480. That's what you're actually saying there. So this is the last step of that whole process. I said I was only going to do numbers. I want to touch on fractions just a little bit because I think it's shown so well in the Singapore math book. You have these long rectangles, and you can see, for example, here that 2/3 is 4/6, 6/9, so on. And they have so many pages of that, so many pages spent on that a child understands it. This is what fraction of a dollar. A little bit of. I like this too. That if you have a model like this, you understand how to do that. 1 minus 3/4 minus 1/4, without the child saying it doesn't have a common denominator. That 1. Do you know what it means? Well, it's just the whole thing. 5th grade, the concept of multiplication. Lots and lots of pictures. Again, I said I was going to only do numbers, but I want to throw in a quick volume unit that comes out of a 5th grade book. They start with actual cubes, of course, the building things with cubes. Then they can use that to try to figure out problems like that. This is a pretty traditional box, 8 times 5 times 6. This is not so traditional, but they can figure it out. Base times height, length times width times height equals 72. You have one thing missing. It's a little bit abstract, but everybody knows that the abstract math is really sexy. Figure out why every once in a while it gets into a little depth there. But then you go on to slightly even more abstract things, like if you know how much water is in something, around here. Can you figure out how much is in there if you put a brick in? Or can you figure out its size? Oh, take that. So you actually do it. And you get to problems that are pretty challenging. It was originally 1/3 filled with water. Put the stone in, it becomes 3/4 full. In other words, figure out the fraction. From the fraction, figure out the height, and then find the volume of the stone. Subtraction, back to mental math. So I'm kind of interspersing a few things in here from the mental math, because if we did it all at once, you'd get exhausted. The first trick in subtracting is, of course, breaking up the second number. 25 minus 8 is 25 minus 5 minus 3, right? 17. That's a wonderful trick. But there's another way to do it. I think I tell the kids that these two numbers are like an uncle and a nephew. So the uncle is 25 and the nephew is 8 years old. How old will they be in 2 years? And will the difference in their ages be the same if one of them doesn't die? Right? They're going to be 27 and 10. Now, is that easier to subtract? Yeah. So you take the second number, add whatever it takes to become a multiple of 10, and then subtract. You'll find it's a lot easier. 27 minus 10. So this is some quality slides. Math is actually easy, as you can see. Anybody can do math, even mental math. Back to our regular stuff, though. Advantages. The third advantage is the approach that this uses to word problems. Fantastic. This is how most children feel about word problems. This Helen's library. So kindergarten, first grade. You start with symbols, and I've got my rabbits there. And you replace, this is actually from you showed us these rabbits. You replace them with
they multiply.
dots. They multiply, it says then. There are more rabbits. Then you replace the rabbits with rectangles, but they still represent a certain quantity. Those rectangles represent rabbits. They just don't have dots anymore. Instead, they have symbols in them or under them. And they add to a certain sum. So that was a whole progression there from real things to rectangles that represent those real things to a sum. And the SiMath4 math calls this part, whole. And we do this over and over again in all through the grades. We use SiMath4 math from first grade up through sixth grade. And the words part, whole show up over and over and over again. So this is the final, more symbolic representation of this problem. 3 plus 4 equals 7. Or the number bond can be shown as that triangle. What it means is that subtraction uses the same model. What if you have part and whole, but a part is missing? 7 minus 3 equals 4. It's the same model as the last one was. 3 plus 4 equals 7. 7 minus 3 equals 4. So this word problem, Sue has 3 books and Jason has 4. How many do they have all together in first grade? Looks almost the same as this problem. Maria has $7 and spends 4. How many does she have left? So they can see the reciprocity of addition and subtraction. So this is a third grade problem. Carlos spent $6.50 on a book and $3.50 on a magazine and paid with a $20 bill. How much change did you give? And there's your model. So we spend actually the whole 6 years, first to sixth grade, practicing model drawing. Because these models are so unbelievably useful. You can do algebra with these things that the kids say take their parents 15 minutes. The parents are trying to do it with x's and y's and stuff. But we'll get to that. This is a third grade problem. So you have the 650, you put a bracket here, and the 350 here, and the question mark shows what's unknown. And the 20 versus the total. So the 3 numbers that are given have to show up in the model. And you just have to decide, is it part, or whole? Well, the $20 is the whole, 650 and 350 are 2 of the parts. The other part is how much change you have here. And then you write out your equations. 650 plus 350 is 10. $20 minus $10 is 10. This change is $10. How do you like the writing out here? Do kids really do that? They really do. If you require it. And that's one of the lovely things about SiMath4 math is that this word problem approach, and they've grown. They haven't told you that, but they've grown when you say word problems. But that's part of the deal, just like cafeteria lunches are, you know. So, so this child drew it a little bit differently than I did, but that's fine. He or she has the $20 as a whole rectangle.